force versus time graphs. Okay, the area under a force versus time graph, let's figure out what it means. So we have an equation that involves force and time now. So if net force times time equals change in momentum, then the area under a force versus time graph must give us change in momentum. All right, because the area is the base times the height. The base is time, the height's the net force. So just like we saw with motion graphs, okay, if the graph is above the time axis, then the change momentum is positive. And if the graph is below the time axis, the change momentum is negative, okay? So this is really not the area under a force versus time graph. It's the area between the graph and the time axis. So what about these graphs? So these are actually velocity versus time graphs, all right? But we're going to use these as a stepping stone, okay? So in case A, I go from 5 meters per second to -3 over the course of, it looks like a second and a half or 2 seconds, all right? And then case B, the velocity change went from 3 to -1 over definitely 2 seconds. So in case A, right, we can tell from just looking at the values of the velocity that case A had the greatest velocity change. All right, the slope of that changing bit is steeper in case A, so it had the greater acceleration. So if we assume that these had the same mass, same object, just in 2 different scenarios, all right, if there was the greater velocity change in case A, then there was also the greater momentum change, which means there had to be more impulse. Okay, so now we actually have a force versus time graph. Okay, so here, all right, what is the impulse delivered by the force graphed in the above figure between time equals 0 and t equals 5? So from time t equals 0 to t equals 4, all right, I have a triangle, all right? So the area would be 1/2 base times height. So 1/2, 4 times 4, it's 1/2 of 16 or 8, okay? So in the first 4 seconds, my impulse was 8 Newton seconds. Your task is to answer this question